Hello, welcome to this talk with Ray Tomes from the Cycles Research Institute at cyclesresearchinstitute.org. We're going to talk about solar ultraviolet emission cycles. Ray, you have a lot of research on this. Tell us a little bit about what's going on with the sun and how it affects us.
Yeah. So this graph I've got up here, they call it solar magnesium 2 core to wing ratio. And it's a particular measurement that's been designed as a good indicator of ultraviolet and extreme ultraviolet emissions. And you can see here we've got about almost three cycles of the 11-year sunspot cycle, and you see there's a moderate range. It's not the huge range that you get in the sunspot numbers where you multiply by 10 or 100. This is from 0.264 here at the lows to about 0.286 at the high, so there's not such a big variation, but there's much more variation here than there as well. So we can see that there are some shorter cycles going on in here as well as the main 11-year cycle. So we perform a cycles analysis using our CATS program.
That's the program that you developed, isn't it?
Yeah, it was expanded for CRI. Now, this is the period, this part of the spectrum. So what we've got here, this is the frequency in cycles per day, going from 0 out to 0.3 of a cycle a day. So in other words, cycle every few days.
Yeah. And
they're labelled here. The first very strong peak is at 26.74 days.
Yeah.
Then there's a second peak at 13.55 days,
Yep.
which is pretty close to half that.
Yes.
There's another, not quite so strong peak at 8.92, which is a third of that. Another strong one again at 6.84 days, which is a quarter of that. And there's further peaks at 5 and 6, fifth and sixth of that, and probably some more here. But we see there's quite a lot of other little things around which tend to, you can't say, well, is it that one or is it that one? You have to go sort of the general vicinity, because there's obviously a lot of other things happening at the same time.
Okay.
Yeah. So we can understand these well because the sun, there's this thing called the neutral sheet that comes out from the sun, which is like a tennis ball seam rather than an equator. And the stuff that we experience at Earth, as this tennis ball seam comes by, you're the Earth, I'm the sun, and this thing comes around like this. And at that point, you're on the seam, and at this point you're on the seam, and again twice more in a rotation. And when you're on the seam, something different happens because charged particles in a neutral field can travel in a straight line. In a magnetic field, they go or so they can't get from the sun to the Earth except along the neutral seam.
Oh,
right.
Yeah.
So that's why every 7 days, 6.84 here, when that seam, which has normally got 4 crossings, you can get more stuff hitting the Earth at those times.
Ray, I have a question about that. It's about 6.84 days in the solar magnesium 2 levels, but that's happening inside the sun, but we are revolving around the sun a little bit in 7 days. Does that have an influence on how we receive it?
Yeah, it does.
Too little time.
No, well, it's significant because the normal rotation period of the sun might be called 26 days, but as seen from the Earth with the sunspots, it's 28. Now this one's in fact somewhere between the two. It's actually about 25.8 and 27.8 for the visible part. So this might be coming from some of the depth. An astronomer, a solar physics astronomer, would be able to better answer the question of why it's that particular period. But there are a lot of fluctuations in the solar rotation rate.
So this 6.84, might it be closer to 7 days?
No, well, it's No, that's what we're seeing. That's what we're seeing from the Earth.
Oh, thank you. So we're seeing how it affects us, how it reaches us here on Earth.
Yeah, that's right. This is what reaches us on Earth. These observations are from Earth.
Yes.
But the sun's rotation varies with latitude.
Yes.
At higher latitude, it's slower. And at the equator, it's faster. It varies with depth. Deeper in the sun has got a faster rotation.
Indeed.
It varies over time, over the sunspot cycle. So what we can say is it's not like the solid Earth rotating as the blob. It's fluid, and different parts are rotating in different places and moving relative to each other.
Yes.
Because there's a lot of dynamic stuff going on with the heat transfers and stuff from below. So so that's
okay.
That's now I've put up here. Let's go to the expanded version of that. In this part here,
yes,
there's some more interesting things happening. So we're going to go to that in the expanded part. and we see that at double
Yes.
the rotation period of the sun, there's also a peak.
Yes.
Another one, approximately at 4 times that. This one's a bit off.
Yeah.
This one's at 6 times,
Yeah.
12 times, and 24 times these peaks. So
Yeah.
there's a cascading effect there, and these ones, we will see these cycles again in other observations of the sun relating to many other things. And there's a group of solar physicists who have reported extensively on cycles near this range, typically saying 154, 155 days. They mention other ones at 77, which might be this one, which is
Yes.
half that. They mention this one at a third of that.
Yes.
And they mention some longer ones sometimes that are harmonically related. So there are these harmonically related cycles that are existing there. We'll go back to this one. I put that as an insert in this one so you can see both at once.
Yeah.
So we've got this extended pattern of harmonically related cycles.
Yeah.
We're divided by 2, by 2, by 3, well that's 2 as well, by 2, by 2, by 2, by 3,
Yes.
by 3, by 2. So there's this lots of ratios of 2 and 3 in them. Occasionally something else, but the 5 one is pretty weak compared to the others. So the basic pattern is lots of ratios of 2 with some ratios of 3 between these. Now, in terms of standard understanding of what's going on in physics in the sun, we expect this one because of this neutral sheet I mentioned.
Yes.
And that neutral sheet isn't always 4 times. Sometimes it's 2 times, 4 times, 6 times. So these other ones are not surprises, these other things, and that these ones are a little more smaller is not a surprise. There's no surprises there. But I think when you go up and look at these ones, I think there is a surprise, because these are harmonics. These are called subharmonics, and a nonlinear system will easily develop harmonics. But subharmonics, especially to this extent and this pattern, is not a very easy thing to explain. I'd like to see someone try.
Yeah.
And the conclusion that I come to, which you can't come to just from this,
Yeah.
but from studying other cycles and much longer ones that relate to these, my conclusion is that in the universe there are these standing waves which have got all these periods coming down, and the sun is synchronized on them.
Oh ho.
Right?
So it's not just the sun influencing us and us reflecting that.
No.
We're both influenced by another larger
Yeah, a
outside
larger
source.
thing here, yeah. So that's the, I think of all the different things that I've studied, this one has, we often find these harmonically related cycles, and we'll find often a few of them in one thing, and a few in something else, some of them the same ones, and we'll get this extended pattern over many orders of magnitude like this. But this is the only case I've found that's got that many of them in one thing.
Yes.
So it's quite unique in that respect. From this one to that one is a 144 ratio, and it's got the ratios of 12 in there, and that's exactly the pattern that harmonics theory predicts.
Yeah.
So this pattern is a very strong evidence of harmonics theory, and it's very interesting in its own right, even apart from that, of what's happening there.
Yes. Hi, David Katzmar from the United States with Ray Tomes of the Cycles Research Institute. Ray, you're going to talk about harmonically related solar cycles.
Yep.
Thank you.
So these are in the shorter cycles. We've talking other times about long cycles of thousands of years, hundreds of years, or 10 years and such. These are ones that are measured in days through to a year or two. I first began to find some of these myself in sunspot numbers back in about the 1970s and 80s that they popped up, and they were pretty consistent over long periods of time. So one of the strongest ones is around about 155 days, and you can trace it through many solar cycles. There are a number of published papers I've come across from different sources, and there may be many more, but when I visited Russia, I was given a book of what's up on the shelf there of cycles in nature.
Yes.
And there's a paper in there by a fellow Nestorov on measuring solar radio, and that finds cycles around 154 days and around 77 days.
Wow.
So those ones are there, and then there's a lot of other. There's a group of other people Riga, I'm not sure how to pronounce that, and Bai, and a number of others who have published a lot of papers on solar flares, microwave, proton flares, and sometimes sunspot numbers, often reporting cycles around 154 days. At different times they've called it 154, 152, 155, 156 days,
Yes.
and they've often done it in one cycle, because they found it mainly during near the maximum period of the sun, and they haven't looked at it in the minimum. As I mentioned before, there's ways of processing it. In the case of the sunspot numbers, I find if you take the square root of the sunspot number, then it gives more equal fluctuations near the solar. Normally you get small fluctuations at the solar minimum and bigger ones at the maximum.
Yes.
When you take the square root, it makes about equal fluctuations. In that case, if you're looking for a cycle that's a shorter cycle like this, it will have more or less equal amplitude through the minimum and the maximum, and you can follow the cycle much better for many solar cycles, which you can't do the other way. So
this worked for you when you were analyzing monsoons.
Yeah,
in
same
India.
thing. Yeah.
Same formula.
Yeah. So sometimes there's a different formula in the square root. There's a function called the lambda function. The square root is one special case of that, which happens to work well for these two.
Yes.
But there's other parameters, and you can choose what's the best value. So these. They also found a 77-day one in solar flares, which is half the 154-day one. And then in neutrinos, a period of 28 days has been found. In 1991, these guys published a paper saying subharmonics of a fundamental solar rotation. And so what they realized is that in different times and different things, they had found these cycles. They'd found ones, these are my values.
Yep.
And I've taken a sort of average of the different things reported by different people, and I've made it so that these are at exact ratios of 2 and 3. Right?
Yes.
So they're typically 154, 155 days, sometimes 152, 156 that they report. But
Yes.
I've used a central value of 154.7 days, half of that. These ones are commonly found. At times they mention this one, which is 3 times as long.
Yes.
And this is the solar rotation period, and double that, which is a third this, which is also found, and this is found. And these different ones are found in a number of different things. So all the bold ones there have been found in various solar phenomenon, most of them a number of times in different things. I should mention there's one little complication on this one. This is the solar rotation period. These are multiples of that.
That was 25.8 days.
Yeah, that's the rotation period at the equator relative to the stars. Often we will see, if we look at sunspots, we'll see that as a 27.8 day period because the Earth's moving relative to the Sun. So sometimes that one doesn't quite fit the pattern, and that's the reason why.
Yeah. So are we talking about sidereal versus synodic?
Yeah, that's right.
Yes.
Yeah. Now, if we continue this pattern of doublings, this structure. The pattern of the harmonic relationships has been observed by these solar physicists and published in peer-reviewed journals. So we can say this is a reasonably well-established and accepted thing that's happening there. What they probably aren't aware of is that this structure with the ratios of 2 and 3 is very, very similar to that which was reported by Dewey in common cycles and many other things in the economy and other things. Dewey found that most of the cycles he found fitted that pattern, but not all of them. There were a couple of oddballs. One of the oddballs, which is a very commonly reported cycle, was one that's in the stock market and also in some interest rate things and so on, which Dewey called a 40.68 month cycle. It turns out that 40.68 months is 1,238 days, and it's if we continue this doubling pattern, we hit that exactly.
Wow.
This one, 619 days, is one that I have found as a weak price, and weak price is fluctuation. So this pattern, we can say, here are some commonly reported cycles in a number of phenomena, many to do with the sun, but we also found this set of 4 here in the monsoon.
Yes.
And this pattern is similar to the one Dewey found, but doesn't fit his other main one. However, if we divide the main set that he's got by 7, we get exactly these, very accurately. So we can say that Dewey was using ratios of 2 and 3.
Yep.
We actually need a ratio of 7 below those to get to this, and we need a ratio of 5 above that to get some of the longer cycles, like the 11.1 and 22.2 solar cycle. a ratio 5 above the pattern that Dewey had. So we see that this pattern is extended upwards and downwards by these other ratios, exactly what the harmonic series says will happen.
Whoa.
So that's so we can link that into the harmonic series as well.
Yes.
But this is interesting in its own right, this pattern of things. They refer in their paper to these ones as subharmonics of the solar rotation.
Yes.
Now, we saw in the case of the magnesium measurements of the sun, we saw the solar rotation, and we saw fractions of it and multiples of it. The thing is that, including some of these periods, the thing is that it's relatively easy with physics, with nonlinear systems, to explain the development of harmonics. And it's very common and very well known and understood in physics why you get harmonics in those nonlinear systems. Subharmonics are much more difficult, I think, to explain by any normal physical process, especially to this extent of this many and only selected ones that are at ratios 2 and 3. Why doesn't the 7th subharmonic exist, or the 11th, or some other one, you know, of that? Well, in fact, the 7th might, and those other things as I mentioned. But that's, I think that they would be looking at this in terms of standard physics. They would, and it would be hard to understand why those would come from this. My argument is these cycles exist outside the Earth, outside the Sun, outside the solar system. Some of the other cycles we're linking to are known to exist outside the solar system. And my argument is that there are universal waves, standing waves, oscillating with those periods, and that those are coming down, cascading down, and that the result is that the sun's rotation has locked into this universal pattern.
Okay, so let me reflect here a little bit on what you're saying here with the subharmonics. It's pretty hard. You can explain why you have a cycle that will be broken down into smaller parts within it, and halves and thirds and what have you, just as you find in music. But to explain why a cycle will then double and quadruple and go on beyond that is very hard. So we're not perhaps really seeing that. When we observe that the doubling and the quadrupling and on and on and on is happening once we discover the small cycle, it's not that the cycle itself is producing the longer waves, it's that was the result of a longer wave that's out there.
That's produced this.
So it's not just the sun influencing us, it's that the sun and the earth are both being influenced by the same thing, with longer waves that break down into smaller harmonics that are reflected in the sun influencing us.
Yes. And these longer waves are universal. We've talked about some of the long ones before, and we will talk about other ones that are relating to the stellar waves and the galactic waves and so on. These ones we find in every scale that's been studied there's regularity. With the planetary one we've done, the spacing of the planets and so on, we'll find that this is reflected again and again at different scales in the universe, and the pattern pervades right through them all. We can find the linkages of the patterns at integer ratios, typically 2 and 3, but sometimes a 7, like we mentioned there.
Wow.
So that's going on. So I haven't dealt much with the physics of this. There's a paper on the Cycles Research Institute website, and it gives a lot of references there to these published papers on these individual things. If someone's interested in that side of it, they should look at those.
And we'll cross-link that when we post this video.
Yes. Okay.
Okay, thank you, Ray Tome, cyclesresearchinstitute.org, for explaining that to me. Your research is magnificent. The numbers are remarkable, the cross relations. There's a harmonics in the research done by various people, how they connect together, and you have found the connecting roads. Thank you for your research, Ray Tome, Cycles Research Institute.